I student Kannan here. Now we see rank of the matrix PYQ. We can find a rank of the matrix from the echelon matrix. It is a very easier method. This matrix A is the echelon matrix. Why this is the echelon matrix? There are four conditions. First condition is all leading entries are non-zero. Okay, what are the non-leading entries? This one is a leading entries, 5 is a leading entries, 3 is a leading entries, 1 is a leading in the fourth row. Okay, so or pivot elements. This is called pivot element. So first condition is all leading entries are non-zero. Leading entries or pivot elements are same. What is the use of a pivot element? Pivot is a non-zero element in a matrix that is used to create zero below it. Okay. Take the first column. 1 is a pivot element. Below the pivot element, all the elements are zero. Similarly, in the second column, 5 is a pivot element. Below it, all the elements are zero. Okay. That is the use of pivot element. So pivot elements are used to create zero below it. Okay, in the corresponding columns. Okay. So first condition for echelon matrix is all leading entries are non-zero. Okay. And second condition is zero row is always below the non-zero rows. Zero row means all the entries in the row in a matrix is zero, then it is called zero rows. Okay, fifth row is a zero rows because all the elements are zero. That is always in the bottom. Okay, so second condition is all zero rows are below the non-zero rows. Okay. Third condition is all the entries below the leading elements in the corresponding elements are zero. Okay. Take the first column. 1 is a leading element. All the elements below 1 are 0. Okay. Similarly, take the second column. 5 is a leading entry. Below the elements are 0. Okay. So that is the third conditions. So third is all the entry in the column below leading entry are 0. Okay, and fourth condition is take this echelon matrix. In the second row, 5 is the leading entry. That leading entry is right side of first row. Okay. Similarly, in the third row, 3 is a leading entry. That is column is right side of leading entry 5. Okay. So all leading entries are always in the right side of leading entry in the row above it. Okay, that is the fourth condition. So each leading entry of a row is in a column right of the leading entry in a row above it. Okay, Each leading entry of the row is in a column right of the leading entry in a row above it. That is, take the second row, 5 is in the second column. That is, that 5 is right side of one of the first row. Okay. Similarly, in third row, 3 is in third column, that entry is right side of 5. Okay. In the fourth row, 1 in the fourth column, that column is right side of 3. Okay. So these four conditions are satisfied, then only the matrix is called echelon matrix. Okay. Now we see some example for echelon matrix. Identify the echelon matrix. Okay, matrix B is 1 2 3 0 0 0 0 0 2, C equal to 0 5 6 0 5 6 3 0 5, D equal to 1 2 3 1 0 1 0 0 5, E equal to 1 2 3 0 5 6 0 0 3. So take the matrix B. B is not a echelon matrix because in the second row all the entries are 0. That is called 0 row. 0 row is always below the non-zero rows. 0 0 2 is a non-zero row. But in this matrix 0 0 0 entries are above the non-zero rows. So it is not a echelon matrix. Okay. So it is not a echelon matrix. Okay. And second one, the element 0 is the leading entry in the first row. So this is not correct. Okay. So all leading entries are always non-zero. Every row, all leading entries are non-zero. Here 0 is a leading entry in the first row, so it is not a echelon matrix. So it is not a echelon matrix. Okay. In the third matrix, in the second row, take the second row, number below the leading entries are always 0. Okay. In this place we get 0, then only it is called echelon. Okay. So here this is non-zero. This element 1 is non-zero. Okay. The element below the leading entries are always 0. So in the second row, A21 number is equal to 1. It is not equal to 0. So this is not a echelon matrix. Okay. It is not a echelon matrix. So the entries below leading entries are always 0 in the corresponding column. Then only the matrix is called echelon matrix. Okay. Fourth one is this is echelon. This is in correct form. Okay. All leading entries are non-zero. Okay. Number of zeros in the third row is greater than number of zeros in the greater than or equal to number of zeros in the second row. Okay. All the entries below the leading entries are 0. So it is a echelon matrix. Okay. From the echelon matrix we can find the rank of the matrix. This is the easier method. We find rank equal to rank of the matrix equal to number of non-zero rows in the echelon matrix. Okay. That is the result. So rank of the matrix equal to number of non-zero rows So in a echelon matrix, okay, this is very important. So in the following problems, to find the rank, we use this, okay. Rank of the matrix is equal to number of non-zero rows in a echelon matrix. Now we see the PYQ problems in GATE, okay. So GATE 2000 instrumentations. Question: the rank of the matrix A equal to, so 1 2 3 3 4 5 4 6 8. Options are 0 1 2 3. Okay, given matrix is, so 1 2 3 3 4 5 and 4 6 8. Okay, now, but this is not echelon matrix. We change into echelon matrix by elementary row operations. Okay, by using elementary row operations, first of all we change the matrix into echelon matrix. Okay, so the condition for echelon matrix is all leading entries are non-zero. Okay, below the leading entries are always 0 in the corresponding column, and the 0 row is always in the bottom. Okay, using that we form a echelon matrix. In this matrix, note that in this matrix, one is a pivot element. Okay, this one is a pivot element. This one is a pivot element. So using this pivot element, we change the element 3 and 4 into 0 by using row operations. Okay, then first leading entry is 1. Using that leading entries or pivot element, we change 3 and 4 into 0 in the first column. To change into 0, use the elementary row operations. Okay, 1 2 3 are in R1, 3 4 5 in R2, 4 6 8 are in R3. Okay, so multiply first row by 3 and subtract from second row, the element 3 becomes 0. Similarly, multiply first row by 4 and subtract from third row, the element becomes 0. That is called elementary row operations. Okay, that is R2 implies R2 minus 3R1, R3 implies R3 minus 4R1, then 3 and 4 become 0. Okay, so to change in echelon form, all the entries, note that all the entries below the leading entries are always 0 in the corresponding column. Okay, that is called echelon matrix. So I am using the elementary row operations. First elementary row operation is R2 implies R2 minus 3R1. Okay, multiply 3 by 1 and subtract from the second row, then only 3 becomes 0. Okay, multiply 1 by 3, subtract from 3 from the second row, then it automatically it becomes 0. That I used. Okay, so 1 to 3, don't write no change of first row. Okay, only changes in the second row and the third row by using elementary row operations. So 3 minus 3 is 0. Multiply 3 of first row, multiply first row by 3 and subtract from second row. Okay, 3 2s are 6, 4 minus 6 is minus 2 here, 3 3s are 9, 5 minus 9 is minus 4. Okay, and R3 implies here 1 in the first row, 4 in the third row, multiply 1 by 4 and subtract from third row, it becomes 0. That is our aim. Okay, our aim is change 3 and 4 into 0 by using 1, by using elementary row operations. So R3 implies R3 minus 4R1. Okay, multiply 1 by 4 and subtract from 4. 4 minus 4 is 0, 4 to 0 8, 6 minus 8 is minus 2, 4 into the 12, 8 minus 12 is minus 4. Okay, this is equivalent matrices. These are called equivalent symbol. Now in the second row, minus 2 is a leading entry, pivot element. This is the pivot element now. Okay, pivot element is always non-zero in a matrix that is used to create 0 below it. Okay, now using this minus 2 in the second row, we change the number minus 2 in the third row into 0 by using the same operations. Both the numbers are same, so just directly subtract and write change as 0. So now write R3 implies R3 minus R2. Okay, there is no need of multiplying any scalar with the second row because both the numbers are same. Okay, so we subtract. So 0, 0, so minus 4 plus 4. Okay, minus 4 minus of minus 4. Similarly, minus 2 minus of minus 2. It becomes 0. Okay, so note that this matrix is a exactly echelon matrix. Okay, because the leading entries are non-zero, the elements below the leading entries are 0, 0 row is in the bottom, 0 row is below the non-zero rows. Okay, so this is exactly echelon matrix. After changing to echelon matrix, we can write the rank. Okay, rank of the matrix is equal to number of non-zero rows in the echelon matrix. How many non-zero rows here? 2 non-zero rows. Okay, 1 2 3, 0 minus 2 minus 1. Non-zero row means at least one element of the row is non-zero. Okay, so rank of the matrix. Okay, row, that is a symbol to use for rank. It is equal to. So which option is correct? C option is correct. Okay, so answer is C. Okay, so next problem. Get 94. Question. Rank of the matrix. Zero two two 7 4 8 minus 7 0 minus 4 is true or false? Is 3 true or false? Okay, I am taking the matrix as A. 0 2 2 7 4 8. Note that in the first row, 0 is in the position of A11. Okay, but to form a echelon matrix, all leading entries are non-zero. Okay, here 0 is not a leading entry, so we have to change the row. Okay, we change first row and second row, first row into second row into first row. Okay, we interchange the rows of first one, second one. Okay, so that is one of the elementary row operations. If you interchange, then sound become leading entry. It is correct. Okay, leading entry is always non-zero. Okay. So to change leading into non-zero, I am interchanging the rows of 1 and 2. Okay. So I am interchanging the first row and second row first. In this problem, this is the first step. Okay. We can't change into echelon matrix by using 0 as a leading entries. Okay. Now the 7 is a pivot element. Now it is correct. Because it is non-zero. What is the use of pivot element? Pivot is a non-zero entry in a matrix which creates zero element in the corresponding column below it. Okay. So using the 7, I am making other entry into 0 in the corresponding column. Okay. So in the second row, let it is 0. Not necessary to change other elements. It is already in 0. Okay. Only I am changing this minus 7 into zeros. Okay. So just add first and third row, automatically it becomes 0. Okay. First step is we change entries into 0 by using leading entries in the corresponding column. Okay. Now R3 implies no change of second row because 0 is already there. I am adding third and first row. Third row, first element is 0. Okay. R3 plus R1. No change of first row. Second row, this becomes 0. 0 plus 4, 4. Minus 4 plus 8 is 4. I just add. Now take the second row. Now this 2 is the pivot element. Now we using this 2, we change this number. Four into 0 by using row operations. Okay. Multiply second row by 2, it becomes 4. Then subtract from this 4 in the third row, it becomes 0. So now A is equal to, so R4, R3 implies R3 minus 2 into R2. That means multiply second row by 2, subtract from 4. Okay. Multiply second row by 2 and subtract from corresponding third row. Second row as it is, 0 minus 0, 0. 2 2s are 4, 4 minus 4, 0. Again 0. Okay. Now this is a echelon matrix. In the last row all the elements are 0. That is below the non-zero rows. So we know rank of the matrix is equal to number of non-zero rows in the echelon matrix. So rank of matrix is equal to number of non-zero rows in a column. Here rank of the matrix is equal to 2. Okay. So option is, the answer is true. Okay. Sorry, false, because given that the rank of the matrix is 3, so answer is false. Okay. So next question.